Hello friends, today's question. A 0.1 kg mass is suspended from a wire of negligible mass. The length of the wire is 1 meter and its cross-sectional area is 4.9 into 10 raised to power minus 2 meter square. If mass is pulled a little in the vertical downward direction and released, it performs simple harmonic motion of angular frequency 140 radians per second. If the Young's modulus of material of the wire is n into, there should be no minus sign here, n into 10 raised to power minus 10 raised to power 9 Newton meter square, then the value of n is. So we have a, you can say, wire. So let us draw a wire, and it has a mass. Let us suppose that mass is given as small m, and it is pulled in a downward direction, and by pulling downward it executes a simple harmonic motion. So there will be a small extension in the wire as it is being pulled. Let the extension be delta L. So we can say this is the small extension. Now the mass is at this position, and this is the little extension in the wire, that is delta L, or we can say change in the length of the wire. So initially L was the total length, and now this length becomes, up till here it will be still L, and the extension will be your delta L. So we are going to use both the Hooke's law as well as, because it is performing SHM, so there will be also a restoring force acting on this, and so we are going to combine these two and trying to solve that for the value of n. Okay, so we are going to find out Young's modulus y, and that value will become something, and that from that we are going to find out what will be value of n. Therefore we can say this is our initial condition, and this is our final condition. So we know that the Young's modulus for a stretched wire can be, not the Young's modulus, but we start from the Hooke's law, and which says that the force for the stretched wire, if that is given as F, then F will be equal to K multiplied by delta L. Here the K is our, you can say, spring equivalent to the wire. So let us start from the Hooke's law. So we can say Hooke's law for stretched wire can be written as F is equal to K multiplied by delta L, where delta L will be the extension in the wire, and K, we can write that this will be equal to spring control of the wire, spring constant, spring constant of the wire, because the wire should be having some spring property. That's why we are calling this K as a spring constant of the wire. If the spring doesn't have the wire doesn't have a spring property, then it won't be executing a SHM. It will not able to, you can say, possible to vibrate. That's why it's called as a spring constant of the wire. And the Young's modulus that is given as y and y is our stress oblique strain. And here I forgot to mention that F is applied force. F is the applied force. So stress will be equal to force oblique area, and strain will be equal to delta L upon L, where L is the original length and delta is the change in length, F is applied force, and A is the area of cross section. So from here we can say that A is cross sectional area and F is applied force, L is the original length of the wire. Original length of wire. So from here we can find out value of F. So we can see F is equal to, this becomes Y multiplied by A multiplied by delta L and divided by A into L. Okay, I think let me sort it out first. Here this becomes L A into delta L. Okay, now it's correct. So we can equate, this is also the applied force equation, and this is also the applied force equation, and first we need with the help of the Hooke's law, and another one is from the Young's model of elasticity. So we can equate, let us call this equation number 1 and this as equation number 2. So we can say from equation 1 and 2, from equation 1 and 2 we get YA delta L upon L will be equal to K multiplied by delta L. Delta and delta L cancels out. From here we can write that our K will be equal to YA multiplied by L. So this we got the expression for the spring constant, which spring constant of the wire rather, and we also know that the equation for SHM, because the wire is executing the SHM as given in the question. So we can write the equation of SHM, and when a body is executing SHM there will be restoring force acting on it. So you can say for a restoring force F will be equal to minus K multiplied by X, where X is the displacement from the equilibrium position. So X is our displacement from the equilibrium position. So therefore the equation of the motion we can write that F will be equal to mass into acceleration. So substituting we get our mass into acceleration is equal to minus kx, and acceleration we can write double derivative of our displacement, that is x. So you can say from here m double derivative of x with respect to time minus kx, and this can be re-modified as the standard equation for your SHM, giving us k upon m x is equal to 0. And from here, which is standard equation of SHM, we can write that the angular frequency will be equal to square root of k upon m. So we found out that value of omega, and we already know the equation for k, that is spring constant. Therefore we can write that omega, let me call this equation number 3. So I can write from equation 3, we get omega is equal to, and we get this is ya upon lm square root, and this gives us a relationship between the angular frequency and Young's modulus. Okay, we can write this gives the relation between Young's modulus and angular frequency. And if this relationship is known to you, you can use directly the formula and find out the Young's modulus y. And if you don't know, this is the way to drive it. So from here we are supposed to find out y. So we can write y will be equal to omega square lm upon a, and omega is given as 140 radian per second. This comes 140 square. Length is given as 1 meter. Mass is 0.1 kg. And area of cross section is given as 4.9 into 10 raised to power minus 2. So this gives us 4 into 10 raised to power 9 and Newton meter square. I think this should be, I think it looks correct. But we are given that y is equal to n multiplied by 10 raised to power 9. So if we make a comparison from here, we can say value of n is equal to 4, which we are supposed to find out. So we can say this is the value of n, and yeah, this was supposed to find out. So n is equal to 4. So this completes the question. Thank you.